Hello, everyone. Welcome back to AIQuantEasy. Starting from this episode, we will talk about supervised learning on stock prediction. We will start with the simplest supervised learning model, then gradually go deeper until we use the state-of-art AI technology, like ChatGPT type of thing. So stay tuned. Here is the enriched stock daily price data that we have so far. We have open, high, low, close price, the trading volume of that day, and a variety of derived indicators as extra features for each day. Because of space limitation, we only show some of the indicators, but in reality, we can have way more. Assume what I want to do is to train a machine learning model that is able to make a prediction if a given day is a good day to buy shares or not. If the model tells me that today is a good day to enter positions, and if I trust this model enough, I might buy shares at the close of the market using the close price. For such a task, again, we will start with a simplest supervised learning model. In order to train a supervised learning model, we need to have training data. So what is training data? Training data is historical records with a label attached to it. So here we have the historical daily price information, right? And we also attach a label to each day. So this label indicates if a historical day is a good day to purchase or not. So here you can see that 1 represents that this day is a good day to enter positions. 0 means otherwise. You may ask me how I can attach such a label to each day. I will tell you later in this episode. But here we just simply assume that we have such a labeled records. The labeled records then can be used as a training data to train the supervised learning model. Of course, we need to have a good amount of these records with labels, right? We need to have a good amount of data, training data to train our model. Assume that is the case. Let's say how supervised learning model is trained. So here is our training data. Again, we have a lot of those labeled records, okay? Then we will feed all these labeled records into a selected supervised learning model to train this model, okay? After this model is trained, then given a day without a label, then this model is supposed to make a prediction of the value of the label. So in other words, through the training process, the supervised learning model actually learns how to map the values of the features of each day to the value of the label of that day. They build the relationship between the values of these input features, including all these prices, volume, and all the values of these indicators, towards the values of the corresponding label. Okay, once this supervised learning model is trained, again, given a day without label, this model should be able to make a prediction if the label is about 1 or 0. 1 represents is a good day to purchase, 0 means it's not a good day to purchase. Let me put this model in a practical scenario. In the current day, when the time is near the close of the market, at that time, I have the open price. I can use the current high, low, close to approximate the high, low, close of this day. Although we are not at the close of the market yet, but this approximation should be precisely enough. I can also use the current volume value as the volume for the whole day. Once we have this open, high, low, close volume, then we can derive all these indicator values. Then we feed this record into this trend model. Then the model should give me a predicted value for the label. If the predicted value is 1, and I trust this model enough, then I can buy shares at the close of the market using the close price. Now the question is how we attach a label value to each of the historical stock daily record. In other words, how do we define if a day is a good day to enter in a position? There could be different ways to define what is a good day, as long as your definition brings you more opportunities of profits than loss. A simple definition could be if the open price of the next day is higher than the close of the current day, then the current day is a good day for entering a position. Based on this definition, let's just label each of these 5 days. So each of these represents a price candle of that day, right? Based on this simple definition of a good day, let's just examine each of the days, how we label them. Look at the first day. So the close is here. Then the open of the next day is here, which is lower than the close of the current day. So this day is not a good day, so we label it as 0. The same for this day, right? So the close for the current day is lower than the open of the next day. So this one should be labeled as 0. How about this one? So the open of the next day is here, which is higher than the close of the current day. So we define it as a good day. We label it as 1. Let's look at this one. The close price of this day is here, and the open of the next day is here, which is lower than the close of the current day. So by this definition, we label this day as 0, which is not a good day for entering a position. By other definitions, this could be a good day, right? But by this definition, this is not a good day, so we label it as 0. Now let's look at another definition. This definition is more complex. The definition is as follows. Starting from the current day, which I want to give a label to, I examine each of the following days one by one. If the stock price reaches 5% or more increase compared to the close of the current day, before it reaches 2% or more decrease, then I label the current day as 1. If this is not the case, I label the current day as 0. I would use the following 3 examples to illustrate this definition. So for the first example, I want to label day 1 for stock XYZ, right? The close price for day 1 is 100. So in order to label day 1, I examine each of the following days one by one. I go to day 2. I look at it as a high price, 102, which is just a 2% increase compared to the close of day 1. This is less than 5% in the definition, right? I look at a low as well. So this is 1% decrease, which is also lower than the 2% decrease given in the definition. I cannot make a determination by looking at day 2. Then I go to day 3. For day 3, I don't have 5% increase. I don't have 2% decrease. I cannot make a determination. I go to day 4. Same thing, right? I only have 3% increase. I don't have 2% decrease, right? Then I go to day 5. For day 5, I'm looking at a high. I have 6% increase, which is more than 5% increase compared to the close of the day 1. And I don't have 2% or more decrease for day 5. So in other words, starting from day 1, okay, go forward, I see 5% or more increase on the stock price compared to the close of the day 1 first, before I see 2% decrease. According to this definition, then I will label day 1 as 1. So in other words, day 1 is a good day for buy shares. So in other words, if you buy shares and at the close of the market, with a price 100, then you will see 5% or more increase of your stock price first before you see any 2% or more decrease. Let's look at the second example. Again, I want to label day 1. So in order to label day 1, I examine the following days one by one, right? For day 2, the same as the previous example, I cannot make determination. Day 3, same. Go to day 4. So here, the high is 103, which is not 5% increase compared to the close of day 1. But the low is 97, which is a 3% decrease compared to the close of day 1. So according to this definition, I see 2% or more decrease first before I see 5% increase. So in this case, I should label day 1 as 0. In other words, day 1 is not a good day to buy shares. Let's look at the third example. Again, I want to label day 1, right? I examine day 2 first, cannot make determination. Then day 3, cannot make determination. I go to day 4. For day 4, the high is 106, which is a 5% more increase compared to the close of day 1. At the same time, the low is 97, which is more than 2% decrease compared to the close price of day 1. So in this case, 5% increase and 2% down occur in the same day. So in this case, I cannot determine which event occurs first. So in this case, I label day 1 as 0 as well. Okay, now we will see how we implement this definition by adding labels to my daily stock record. Now let's look at the code to see how we implement the labeling strategy that we just discussed. The first part of the code is the same as what we discussed before. We load the SPY daily data from Yahoo Finance. When we train a machine learning model, we want to load as many records as possible from Yahoo Finance. But here, I want to first show you the labeling strategy. After I implement the labeling, I want to visualize the labeled stock data as well. In order to make the visualization looks clean, I here just load 1 year worth of data. Again, later on, when I try to train machine learning model, I will change it to max, okay? So after loading the data, we derive a variety of indicators. Then we visualize the stock data and all those indicators. Now let's focus on this labeling parts. So I define a function called label data to label each day, right? So I first initialize a list with size n represent the number of days that we have in our data frame. And every day's label will be initialized to be null value. Then I start to label each day, right? So here I have a loop to loop over each day in my data frame. So for the ice day, in order to label the ice day, what I need to do is I will check each of the following days one by one, right? To say if I say 5% or more increase before I say 2% or more decrease or not. If it is, then I will assign 1 to this day, right? If it's not, I will assign 0 to this day. Okay, so basically, this is where we check each day, each of the following days of the ice day to say if I see 5% or more increase or not, right? If this JS day is high compared with the close of the ice day, is 5% or more increase. At the same time, for that day, the low compared with the ice day's close is not 2% or more down. Then basically I see 5% or more increase first. If that's the case, I will assign 1 to be the label for the ice day. Once I have this label for the I-state determined, I break out of this inner loop, then start to label I+1 day, right? So if I didn't say the 5% increase, then I will check if I have this 2% or more down for JS day. If I do, that means what? There's no opportunity for me to say 5% increase, right? Before I say 2% down for I stay. So that means I need to assign 0 to I stay, right? If I are able to assign 0 to I stay, also I break up from the inner loop. That means I already determine which label I need to assign to I stay, right? Then I move over to I+1, continue to do the process. So finally add this list of labels as extra columns to this data frame. So that's basically how I label the data. By using the strategy we discussed earlier, right? If we say 5% or more increase before we say 2% or more down, if that's the case, 1, otherwise 0, right? So I want to visualize the label data. So here, basically, is where I want to label I want to visualize the label data. Basically, what I want to do is I just want to add signals to those days which are assigned with 1. And also, I want to add some different signals to those days which are labeled as 0. Okay. So what I want to do is if a day is labeled as 1, I want to add up arrow signal right below the candle of that day. So for example, if this day is labeled as 1, I want to just add a up arrow as a signal right below the candle of this day. In the opposite way, if a day is assigned with a 0, then I want to add a signal of down arrow above the candle of that day. Okay, so in this way, I can clearly say, oh, what are the days labeled as a 1, which represent good days? What are the days labeled as 0, right? Okay, so let's just look at the code for visualization. Basically, I define 2 methods. One is called ones, and the other is called zeros. Ones is a method basically generate signals for the days with label 1, and zeros, the methods that generate a list of signals with the days has a label value 0. Okay, let's just look at the method once to see how it works. So this method will take 2 series as a parameters. The first one represents the label column of the data frame, and the second represents the low price column of the data frame, right? So I initialize the signal as an empty list. Then I use this method called iter items via this labels column. Basically, this iter items allows us to iterate over this series or over these columns pair by pair. So each pair actually is an index and a value pair. We say each column of my data frame is indexed by date. Every column is indexed by date. So by using this iter items, basically I access every index value pairs one by one, right? And again, the index is a date. So for each date, which is the index value pairs, I check if the value equal to 0 or not. The value basically is the value of the labels, right? So it's the label value we assign to this day. If the value equal to 1, so that means what? This is a good day. We need to add that up arrow signal right below a candle bar for that particular day. So I added this signal. So this signal basically use the lows for that day multiplied by 0.995. So the lows of that day basically is the lowest point of the candle of that day, right? Multiplied by a value which is slightly less than 1 means I get the spot right below the lowest point of that candle. So that is where I want to add this upper arrow. Okay, so I add that value as a signal to this signal list, right? Um, if I find that the value is not equal to 1.0, then I just don't add that value to a signal. Instead, I just add a null value, right? The same thing, I do the same thing for the zeros method. So remember that this zeros method will add a down arrow as a signal to those days which have been labeled to be 0. Okay, so the same thing, we use this either items method to loop over the labels, right? For each index value pairs, we check if the value equal to 0 or not. If it's value equal to 0, that means this day is labeled as 0. Then I will get the highest value of this day, the highest value of this day, and multiply by value which is slightly greater than 1. So in other words, I want to get the spot right above the highest value of the candle for that day. And that is where I want to add this down arrow, okay? So I added this value to the signal, right? And if the value does not equal to 0, then I just add a null value to it. Okay, so I call this ones method and zeros method to generate the list of signals for the good day for the first one, and generate the signals for those days are assigned with a 0 as a label value. Okay, once I have these two list of signals, I just add this extra visualization. Okay, remember that when I talk about we visualize the stock data, right? So we can call this make add plot to add the visualization that we want to overlay with the stock daily data, right? So here we want to visualize both one and the signal 0. So signal 1 again is a list with signals, right, for the good days, right? And for those signals, basically what I want to do is I want to, for those values, I want to basically visualize them as scattered upper arrow with green color, right? And the signal 0, remember, keeps the signals for those days with label value 0, right? For those days, for those values at those for those spots, I want to visualize as a scattered down arrow with a red color, right? So basically, I use this made add plot to overlay the visualization of these two signals to the stock data. Then this is where I basically apply all these add plots, to my visualization of the SPY data frame. I make this figure scale to be 3.5 to make it larger, so we can see clearly how each day is labeled, right? And let's run it to see what do we get. Now let's run the labeling and the visualization cell. First, run the labeling part. So they will generate a label for each daily record. And then we run the visualization part. Then it will visualize the labeled stock data. So you can see that we have this green up arrows attached to those days which have the label value 1. And we have all these red down arrows attached to those days with label 0. And these visualizations give us a feeling that our labeling strategy actually makes sense, right? So in the next episode, we will talk about how to train a supervised learning model by using this label data as a training data. So stay tuned.